Welcome back. In this video, we will learn about probability. So, everybody will have a basic idea of what is probability. So, just to state it, it is how likely something can happen. So, let's say we conduct an experiment. So, it can have many outcomes, right? So, each outcome is called as an event. Okay, for example, if the experiment is rolling a die and observing the number on the top, right? So if you have a die, what are the possibilities? So you can get 1, 2, 3, 4, 5, 6. I'm saying a 6-faced die. So you will have these 6 possibilities. And when you roll once, out of this any one can come. Let's say 1 is being output. So that is one event. So if 2 comes, that is an event. If 3 comes, that is an event. So each of this is an event. So I can define the event like this. A is an event that 1 appears. So I can just put A1 and I can say AI is an event that I appears, and I say I goes from 1 to 6. Okay, so if you see this set, so this exhausts all possibilities. That means exhaust all possibility. So it means there are no other outcomes other than this. So if you roll a dice, all the outcomes will fall inside this set. All outcomes fall within this set. So then this set is called as the sample space. So it's represented by S. So the sample space exhausts all possibilities of the outcomes. It exhausts all events, like all outcomes, right? So out of this is some event. So if you want to know the possibility, so let's say all are equally likely. Equally likely events. AI. Equally likely means all are having equal probability, right? So in that case, what we can define is, if we can define the probability as number of favorable outcomes divided by total number of outcomes. So what is favorable? It is connected with the probability of what? Probability of something, right? So if that is number of events that is favoring, or number of outcomes that is favoring this. So let's take the event A to be even numbers. Even numbers appearing. Then what are the possibilities for A? A, I have 2, 4 and 6. So what is n of A? From set theory we know, right? This is 3. And total number of outcomes is, this is S. So total number of outcomes is n of S. Is nothing but 6. So probability of A, probability that even numbers appear, is equal to n of A by n of S. So this will be 3 by 6 for this example, which is 1 by 2. So half of the time we get even numbers, half of the time we get odd numbers. So another way to interpret this probability is, so when you do one experiment once, right, you get one outcome. So with this we can't say, right, what is the probability. So you repeat this experiment some n times, then you will get n outcomes, right? So the probability says that approximately n by 6 times each of 1, 2, 3, 4, 5, 6 will appear. For example, if you do the experiment 6,000 times, then it says 1 will appear approximately 1000 times, 2 will appear approximately 1000 times, and so on. All 6 will appear approximately 1000 times. So this needn't be exact. So this can be like some 999, this can be 1001, but it is approximately 1000, right? It's 1/6 of the total number. So if you turn n to infinity, then we can say this approximation is tending to equality. So P of 1 will be equal to 1/6, right? And P of 2 will be equal to 1/6 of the total. So it is so for 1000 and 6000 case, if we take, it is 1/6, right, approximately. So it will tend to this number 1/6. When n tends to infinity, this will be exactly equal. Okay. So the other way of thinking about probabilities, if you do the experiment large number of times, ideally infinity, you will get the occurrence of each number which is in proportion to their probability. Okay. So now we'll see some definitions associated with probability. Again, we can use the set theory here, right? If I have A is number 1 appears and B is number 2 appears, then what is P of A? It's 1/6, correct? And P of B is 1/6, because n of A and n of B is 1, right? And n of S is 6 in each case. So what is P of A intersection B? So can both number 1 and 2 appear at once? No. So n of A intersection B is 0. So this is 0/6, which is nothing but 0. So this will never happen. That is what it says. What about A union B? So A union B is either number 1 or number 2 occurring. That is saying, so A itself is 1, B itself is 2. So A union B is 1, 2. So n of A union B is 2. So this is 2/6, which is nothing but 1/3. Right? Suppose if I have some C, so even number appears. Now P of A is still 1/6. P of C is, we already found it, right? Here we found. So it's 1/2 for even numbers. So 1/2. What about P of A intersection C? So what does A intersection C contain? It should be even number and number 1 appears, right? So this is 0, nothing, empty set. So this is 0 again. If we take P of B intersection C, so number 2 and even number. So 2 is an even number. So this will contain one element, which is 2 itself. So this is equal to 1/6. So what about P of A union C? So A union C will contain 1 and even numbers. So 4/6, which is 2/3. What about P of B union C? So B union C will be just 2, 4, 6. So which is again 1/2, right? So from set theory, we also had this formula, right? N of A intersection B is equal to N of A plus N of B plus minus n of A intersection B. So if we just divide this everything by n of s, both sides, then nothing will change. But if you see, each of these are the probabilities. So we have P of A intersection B, so this A union B is equal to P of A plus P of B minus P of A intersection B. So you can try to like take one and substitute and try to see. So P of A union B is 1 by 3. What we have on the right side, 1 by 6 plus 1 by 6 minus 0. So this is also 1 by 3. So it is holding. You can try to check for the A and C and B and C case also. Okay, so this is some important formula. And if A intersection B is 0, what does this mean? They are, A and B are mutually exclusive, right? So when one A occurs, B will not occur, and when B occurs, A will not occur. So this is not 0 actually, and this is an empty set. So A intersection B will be an empty set in that case. So in that case, this n of A intersection B is 0. So this also implies that P of A intersection B is 0. So P of A union B is nothing but P of A plus P of B. Similarly, if we have A complement, right, which is nothing but complement of A. So if A is that dice, like we are observing the dice and 1 occurs, then A complement will be other than 1 occurs. So it will be all the rest 5 numbers. So if A is just containing 1, then A complement will contain 2, 3, 4, 5, 6. So again from set theory we saw that n of A plus n of A complement is equal to n of S, right? So there we add U, the universal space, universal set. Here we have the sample space. So both are like same in the context. So this is true. So from this we can get P of A plus P of A complement is equal to 1, right? So this is true. And P of A union A complement is also 1. And P of A intersection A complement is 0. Okay. So we'll go on to the definitions. So we already defined what is probability. It is how likely anything can occur, right? So how likely something can occur, that is probability. So we defined an event. So what is an event? It is some outcome from a random experiment, right? Some outcome of a random experiment. And then next we'll define non-event. Non-event is nothing but like this A complement. So if A is an event, this A complement, anything except the event, right? Anything other than the event. So that will be a non-event. And then fourth one, we'll see, we already saw mutually exclusive event. Events. So if one event occur, it is guaranteed that other will not occur. Okay. So next we also saw what is equally likely. Equally likely events, right? So all events have same probability of occurrence. For example, if I occurs in a die roll, is a equally likely event. But if we take A1 and A even, then that is not likely, right? A even is number of even numbers. So this is 1 by 6, but this is 1 by 2. So these are not equally likely. But the event that each number occurs is a equally likely event. Okay. Next we have exhaustive set of events. So exhaustive means it is fully covering it. So fully occupied. So if we have events like for this die roll itself, I'll say it A2, A3, A4, A5, A6. So if we take union of all these events, then it will be equal to the sample space, right? So A1 union A2 union A3 union A4 union A5 union A6 is equal to sample space. So this is exhaustive set of events. So next one is independent events. So if I roll the die twice, so what can I say? The second roll is no way impacted by the first roll, right? I'm saying in the ideal case, like you don't do any cheating or something like that. If you take a die and just try to roll it, and if you take the same die and try to roll it again, the second roll is no way impacted by the first roll. So if first roll is, let's say we got 1, then it doesn't say any information about the second roll. Second roll again, it is like it can be anything among these 6, right? So what it means is, we can say is the second roll is independent of the first roll. Okay, so two events are independent if events are independent if occurrence of one does not in any way impact the outcome of other event. So there is a special property for this. So I'll give an example first. So die is rolled twice. So A is first roll, we get an 1. Okay. B is second roll, we get an 6. Get a 6. Okay. So what is A intersection B here? So it is nothing but first roll is 1 and second roll is 6. So since they are independent, right, probability of A intersection B will be, let's say first I throw the die once and I'll find the probability that it is 1. Then I multiply by the probability of B, which is nothing but in the second roll I'm getting a 6. So this is possible only because they are independent. So this is a special property of independent events. Also, if this is true, then we can also say that A and B are independent. So it is like vice versa. Independent. It is vice versa. So either way you go, it is true, still true. So next I want to touch upon conditional probability. So this is nothing but probability of some event given that some other event has already occurred. So what is happening here? Let's take a case of rolling 2 dice. Okay, let's say event A is even number. So I can take only one die, that will be sufficient. Even number occurs, and B is number 1 occurs, and C is number 2 occurs. So now if I say A has occurred, I have rolled a die and some even number has appeared, but I'm not saying you what is that even number. So what this does is, initially before I had this information 1, I'm saying calling it I1. So before I1, what I had the sample spaces 1, 2, 3, 4, 5, 6. But after I1, what happens? I already know it has occurred. So my sample spaces reduced. So now it will contain only 2, 4 and 6. So now I should take probability from this sample space, correct? So what I should do? So this is nothing but A has occurred. So I am only considering A. So this probability is nothing but P of, I will say B given A. Probability of B given that A has already occurred is nothing but N of B intersection A. Okay, so A has already occurred, and whatever the intersection B has with A, only that I am considering, right? Divided by N of A, because now this is my new sample space, right? So B may have terms in this sample space. For example, B is 1, so it is having the term here. But if A has occurred, then B is not present here. So the probability will still be 0, because there is no chance that A has occurred and B also can occur, right? In this example also, if you see, A is even number and B is 1. So if you already say the number appeared is even, then 1 cannot be the possibility. So I have to take an intersection with A, then divide by A. But if you also notice, this is nothing but N of B intersection A by N of S divided by N of A by N of S. I just divide both numerator and denominator by N of S. So this is numerator is nothing but P of B intersection A divided by P of A, right? So P of B given A is nothing but P of B intersection A divided by P of A. So this is also an important formula which can be used in many cases. So for this case, what is an answer? So we know that P of B intersection A. So these two can never occur, right? A and B can never occur together. So this is 0. What about P of C given A? C given A is even number and number 2. So what is the probability that 2 is coming out of the even numbers? It is 1/3. So there are 3 even numbers and 2 is occurring one time. So the probability will be 1/3 out of this, right? So this will be 1/3. If I go by this formula also, it will be N of C intersection A by N of A. N of C intersection A is just 1 and N of A is 3. But what about independent events? So I will take P of A given B. So you can write it this way, so it is easy for you. So this A intersection B by P of B. Okay, consider this. And what if A and B are independent? So I already said, so if what are independent events? Given that one has already occurred, it does not impact the probability of other thing, right? So given that B has occurred, it should not affect the probability of A. So probability of A given B is nothing but probability of A itself. So this you can see from the formula also. So already the formula of P of A intersection B is P of A into P of B, right? So if you substitute back here, P of B will cancel and you will be left with P of A. So for independent events, given that one is occur, the probability of the other is does not change. Okay, this is with conditional probability. So next we'll see. So in daily life you would have heard people saying odds in favor and odds against. So odds in against of an odds in favor of an event, odds against an event. So this is nothing but, if you take the event as A, then odds in favor of the event is nothing but the ratio of probability of A to probability of A complement. So it is the ratio that the event occurs to the probability that event occurs to probability that event does not occur. So that ratio. What about odds against an event? This probability of the event does not occur to probability of the event that occurs. For example, they say odds in favor of India winning the World Cup is say like 70%. Then what it means is, so 70% is nothing but 70 by 100, nothing but 7 by 10. So probability of A by probability of A complement is nothing but 7 by 10. So you also know probability of A plus probability of A complement is nothing but 1, correct? So what will P of A alone be? It will be 7 by 17, and P of A complement is 10 by 17. So actually, like if they say 70%, it doesn't mean more than half India has chance of winning. It means out of every 17, India has a chance of winning 7 out of every 17. That is what it means. Okay. So this much basics is enough for you to start solving the questions. So keep up your practice, and you will see improvement day by day. Thank you.